Good afternoon, class. In our previous session, we discussed about different features of good measurement and we talked about accuracy and precision. A measurement is good if it has high accuracy and high precision. Now we will be discussing a few more features about measuring instruments. As you know that a good measuring instrument should have high accuracy and high precision, but there are more parameters which will define if our measuring instrument is a good one or not, or if you have to select a measuring instrument from the market depending on your need, then you should look into these parameters which are listed on the screen. So the measuring instrument parameters, the measuring instruments are the most important part of measuring process, so their selection have to be done carefully. So for more sensitive measurements, you have to select your instrument more carefully. There are few important parameters as mentioned below that must be considered before selecting any measuring or test instrument. It also goes for your project work when you are doing some kind of project or lab activity. Then you have to select a right measuring or test instrument based on your application. So there are different features which are listed here. For example, the accuracy and precision, which these are the first parameters which we studied for a good measurement. So any instrument with good accuracy and precision is the first parameter or first criteria. Sensitivity. We will discuss some of these features below. Resolution, response speed, how quickly your meter gives out the output reading. Loading effect, if you remember we discussed loading effect before, that your test instrument is giving reading without disturbing your circuit or your without disturbing your machine. Error or tolerance. So if the error margin is minimum, that is good. Tolerance, you know that tolerance is usually given in percentage. For example, when you use resistors, in the data sheet it gives you a resistor 100 ohm resistor plus minus 5% tolerance. It means that that 100 ohm resistor could have plus 5% of resistance value, means it can range up to 105 ohms, or it could have minus 5% range of tolerance value, meaning that its resistance could be less than 100, could be up to 95 ohms less. If you make 5% less from 100, it will make 95. So your resistor value could lie anywhere between 95 ohms to 105 ohms. So that is called the tolerance range. The same thing exists in the measuring instruments as well. The manufacturer provides you how much error possibly it can give. Measuring range, for example, if you are supposed to measure a resistance whose value is approximately 50 mega ohms, but you have a multimeter who can measure resistance of maximum up to 1 mega ohm. So it means you should arrange for a meter whose measuring range is big and who can measure up to 50 mega ohms. So that's a measuring range. Price is another feature, of course. Whenever you are buying something or selecting any instrument, you should look after the price as well, that is it within the budget or not. Okay, some of the parameters we will discuss in detail. Loading effect, as discussed before as well, but it's a brief description is given here. It is the disturbance caused by the measuring instrument to the electrical properties of a circuit. The common electrical properties like voltage, current, and resistance. If you connect a measuring instrument with the circuit, it should not disturb the circuit. It should not disturb its resistance, current, or voltage. So the remaining detail you can read from here because we discussed it before in detail. So I will not go into it anymore. So next is the sensitivity. Sensitivity is the smallest change in a dimension that an instrument can detect. It means you are measuring, for example, current in the circuit. Any small change, a minute change in the current value change slightly, and your meter is a good one, it can detect it immediately. It means your test instrument is sensitive. Sensitivity is the smallest amount of change in quantity under observation that can reflect on instrument reading. So more sensitive instrument with higher accuracy are usually more expensive. So good value comes for good features or good uh, I mean the good performance. You have to pay more for that. The application requirement must be considered to decide on the level of sensitivity of the instrument. So depending on the application, what type of features, what type of parameter you are measuring, that will decide if your meter should be very sensitive or less sensitive. For example, if you are supposed to get a weighing scale to weigh the rice bags, for example. For example, you have a warehouse where you are storing or packing rice into bags of 20 kilograms. I'm giving you an example. You have different packing 10 kilograms, 20 kilograms, 30 kilograms. You are making big bags of rice. So you can buy a scale who is not very sensitive, not sensitive up to giving you accuracy of up to grams or milligrams. You don't need that. Okay, so you can buy a cheaper scale who is less sensitive, which is less sensitive, and it can be with an error margin of let's say 50 grams or 100 grams, doesn't matter when you are weighing 20 kilograms. So 100 grams doesn't really matter. But if you are dealing with some precious metals, for example gold, okay, there you cannot afford to get a scale which gives you an error or which is not that sensitive. And uh, so for precious metals you cannot afford that. For that application you will buy a measuring instrument which is very sensitive. So next is the resolution. Resolution, the resolution of a measuring system is the smallest yet to distinguish difference in value. What does it mean? Here is a picture. Maybe you will better understand from this picture. Imagine this is a scale, the scale which you use in class for drawing. So you must have noticed that on the scale there are markings. So these markings, they gives you the divisions. That some scales will give you marking of centimeters only. So you can only measure this is 1 centimeter, 2, 3, like that. Some scales will give you marking of millimeters as well. So in between these lines, there will be additional lines giving you more more small steps, okay, more small divisions. So using a scale which have millimeter marking available, you can be more precise. You can be more. You can go in depth, in more depth. While with a scale with a marking of only centimeters like the one on the screen, for example, so you cannot go into too much of detail. So this one step distance between one line to other line, that is called resolution. So resolution is basically this gap between one scale division to the next scale division. So the same thing goes for the measuring instrument. If your measuring instrument can measure a small step, a small resolution step, it means it has high resolution. And if your meter is only able to measure a large step, then it means it is having less resolution. I give you an example. For example, you have a voltmeter. You have two voltmeters. One voltmeter will change its reading only after when the reading changes by 0.5 volts. Okay, for example, initially it is giving you 0 volt. Let me see if there is any. Unfortunately, I cannot use a. I'm sharing a screen, so I cannot use a marker to write something. But I'm giving you some example like that. That you have two voltmeters, and one can measure with a division of 0.5 volts. Okay, so if you from 0 you increase the voltage. Okay, then next reading, when you are increasing the knob, the next reading after 0 it will show 0.5 volt. You increase the voltage again, it will not show you any reading between 0.5 and 1. The next step is again 0.5 volts, so it will next reading it will show you 1 volt. You increase again, it will show you 1.5 volt. When you increase more, it will show you 2 volts. So it is showing you reading only after a division or step of 0.5 volt. In between, what is happening, it cannot show you because it has low resolution. So between 0 and 0.5, there are more numbers like 0.1, 0.2, 0.3, 0.4, but your meter is not able to show them because it has not good resolution. So when the reading reaches 0.5, only then it shows it on the screen. You have one more voltmeter which is having high resolution. It can show you the details up to 0.1 volt. So what will happen now? You increase the voltage using the knob and you will see that your meter is showing you 0 to 0.1, then 0.2, then 0.3. So it is showing you all the range in between 0 and 0.5. So it means it is having high resolution. It is giving you measurements of the small steps as well, small changes as well. So that's what it is written here. Resolution of a device is a minimum measurable value of the input parameter under observation. This is very important. This characteristic of the instrument can be changed only by redesign. For example, the measurement, the voltmeter which I gave you example, which is having a resolution of 0.5 volts. If you want to make it more higher resolution meter, you cannot do it. You have to redesign that meter again or remake it. The specified resolution of an instrument has no relation to the accuracy of the measurement. See, accuracy is different thing, resolution is different thing. Resolution is only that how small change it can reflect on the meter, but it may not be accurate. Accuracy is something different. Accuracy means being as close as possible to the true value, true measurement. That is accuracy. So this was all about resolution. In this picture, there are more terms as well. This green arrow, sorry, this is showing the true value. You can see this is the true value. This is our target, that we want to get the true value. Accuracy is if you are close to the true value, you are accurate. A meter, this arrow here, this is showing a measured value. So your measured value is far, is away from the true value by 3 divisions. You can see that in between here. There are 3 divisions here, and you are far by 3 divisions from the true value. So this difference is called error. So error is the difference between true value and measured value. And what is resolution? Resolution, as I explained earlier, that it is uh, the, the smallest division or smallest measurement which your meter is able to record or take. Okay, so the error, the same thing, it is the difference between true value and the measured value. What is true value? It is the average of an infinite number of measured values found by the experimental. So true value, how to find the true value? There is a method and there is a definition that you take infinite number. Infinite means after taking a large number of measurements, after doing so many experiments, you find the average that you assume as a true value. And the measurement value is the estimated value of the true value. How is it estimated? Because you are using some kind of test instrument to find that value. So that is the measured value. So there is one more term called calibration, which is very important. You know, whenever you are using measuring instruments in the lab, after some time, they start giving error due to different reasons, due to the continuous usage or the battery get weakens or the environmental effect reduce the performance of the test instrument. So what happens, they after wear and tear, their reading is not as accurate when they were new. So how to fix that problem? You cannot throw instruments away and buy new one all the time. Some instruments are very expensive. So there is a process of calibration. Calibration is the process to maintain the accuracy of the instrument. So there are different companies to whom you send your meter for calibration. They fix your meter or they adjust your meter reading according to the manufacturer standard, and that process is called calibration. For example, when you provide 1 volt, your meter always shows 1.2 volt. So it means it is always giving an error of 0.2. It is giving 20% extra value. So you send it to the companies. There are companies who do this calibration job. They will fix your meter. They will adjust it from inside, and so that whenever the reading is one, the voltage you provide is 1 volt, the meter should also read as 1 volt. So this process is called calibration. So these were the few important terms which I wanted to highlight to you. Why we studied these terms? Because whenever you are selecting a measuring instrument, you have to take care of these parameters. Okay, so based on these parameters and based on your application, you decide which meter should be suitable for your usage. Okay, guys, so I will stop the recording and open the question answers.